Hello and welcome to another Houdini video. This video I will share a technique about how you can find the angle between two edges, like these edges, and for example if you have the edges with different angle. So if I click here, I just have a basic curve, and especially if you want to do like precision modeling, and in some case you want to calculate the angles between these edges, and based on that do some modeling task or other stuff or generate some attribute. You can use this technique. I think is very useful, especially in procedural modeling. So yeah, I just had a personal project. I had this problem. I needed to figure it out. Maybe there is already a way in Houdini, maybe a node or something to do that. But please let me know in the comment if you know easier way to do that, so I can. Is going to help me a lot. But this one, so I just needed to figure it out how to do it, and the way I just did it is just only just some VEX code, and it's not complicated at all. It's very simple, and it give you a lot of options, and you can just create like a lot of create like if statements and stuff, and between the angles change some parameters or create groups. So I will just go through the code and create everything from scratch, but try to be fast because I think it will be a little bit long video. So yeah, because I want to just explain some basic concept about the dot product and stuff. So let me just create a new scene and just create a geometry, go inside and create a curve. And here is going to top view and change the primitive type to polygon, and also I turn on snap to grid, and let's just do a simple, like imagine this is for a building if you want to, and maybe this one I just connected to here so we can get different angle between these 2 points. And okay, so basically what we have to do is we need to calculate these the angle, for example, between, let me just use this one, I think is easier to draw on screen. So here you have some angle between these two edges, and here is different. You have the different angle here, and here is also different, and the same for other parts. So you need to just calculate this, the angle between these two edges. So basically because I'm going to use the points, and based on that, put 2 points, for example, for this one to this point, and from this point we just create like 2 vectors, right? And just calculate this angle, and then we just assign it as an attribute to the point. So let me just create and just write the VEX code for now, and I will explain more concept later. Okay, just create an attribute angle, and I'm going to just open with Alt E. If you press here and Control minus and plus, you can just zoom in and zoom out. This is new feature, I think, in Houdini 19. And okay, so first I need to create a vector, right? We need 2 vector for each point. So I just create a vector and call it like pref point is equal to point 0, and I need to get p, and add ptnum -1. I will explain this why I'm using -1 here. And another vector is next point is going to be point 0 and p, and at ptnum -1. Okay, so basically now we just created, so this one should be point, not pointer, Okay, so this one is going to run on all the points, as you know, because it's the triangle is like you don't need to for loop, so it's already is run over points here, as you can see. So for each point, if I turn on this point number and change the guides maybe to larger font size, you can see for this, for example, for this point is we need to next point and the previous point. Then we can just create two vector, right? So that's why I'm use the ptnum -1 and +1 here. The next I'm just create an integer attribute, call it last point is equal endpoints input 0 and -1. So this one we just calculate basically the last point we have, the number, because we start from 0, as you can see here. We start from 0 to 10, so it's like 11 points, but we need to get -1 because of this 0. So then I will just use the temporary like attribute I at last pt is equal to last pt, so you can see it in here, right? So now all of them has like 12 assigned, and just delete this one. And now here we need two condition, one for the point 0. If I can find point 0 is here for this point, because after when we calculate for this one, the previous point we do is 12, so we don't have like -1, right? And it doesn't know what is the point before like point 0. So, and also for the next one, so for example, if you go for the last number, which is 12, right, it doesn't know what is the next one, because is after that is 0, so it's not going to work. That's why we need just two if statement for that 2 point. Okay, I just write if at ptnum is equal to 0. We just change the vector we already have here, so I can just copy this previous point here to save some time not writing all of these VEX again. So the previous point is going to be the last point, so last pt, here we already calculated, right? So that's why I'm using this one here. And the next one is going to be 1, because we know after point 0 is going to be 1, so it's already here, we have the number. And another if statement is like if at ptnum is equals to last pt. So this one is for the last point 12, and I can just copy again and paste. So for this one is going to be last point -1, and this one is going to be point 0, because we know after 12 is point 0, and this one is like the last point, as we saw, is like number 12, right? So we just -1, and it's going to be 11. Okay, now we just need to, I just want to create an attribute so you can see that it's now it's like a variable, but I want to see you can just recalculate the vector, right? So what I'm going to do is just create a v at previous point vec. You can use any name you want. So is normalize at p minus previous point. Just copy this one, just paste, and this one is the next point, the next direction basically, and this is then the next we already calculated, right? And if I just apply, you can see we get these vectors here, 2 vector. But now you imagine what we did actually for each point. We just calculated this one. So for example, for this point, we just created 2 vector, one from here and one from here, right? Now we just need to get the angle between these two, right? So this is the angle we're going to calculate. And let me just continue. I just create an attribute called f at angle. And just remember here, I just normalize this vector because we don't care about the length of this from this vector from here to here. We just need the direction. That's why I just normalize it. So when we use the dot product, we get the correct result for the direction. Okay, so angle is equals to dot. And now we just need to use the v at previous point and the next point. So we already have this. So just copy and paste. And this one. And this. Okay, so what we basically get here, we just get the number, float number, scalar is from -1 to 1. So I just go quickly explain if you're not familiar with this. This is just the basic stuff, the math stuff, if you want to just for CG. So you imagine if you have like 2 vectors, like if I draw here, one vector from here and another maybe here. If these 2 vectors are perpendicular like this, or I mean we have like a 90 degrees angle, the dot product of the 2 vectors is going to be 0. And if this vector is moving the same direction, it's going to be 1. And if it moves opposite direction, it's going to be -1. Okay, so we just get to this number first, and then we can calculate the cosine of this, and we get the angle in radians. So let me just clear this. And so we already calculated this. Now we get to get the cosine. So I just use the acos function and put it here. So now, as you can see, we have the angle here. But we need to convert this to degrees. So I'm just use the degrees function here. And now we just get the angle between. As you can see, we have a lot of like 90 here, because most of these edges are like 90 degrees. But let's check 0.0 and 0.12, what we get. 0.0 is 180. And sorry, let me just sort. Yeah, is 146, and for 0.12 it is 124. So you can see here, or for example, between 0.6, let me check 0.6 to make sure if it's correct. This is the 0.6. As you can see here, from these two, we have the correct angle. So it is like 180. I think we should also get the same for 0.2. Let me check. 0.2 also is 180. So this is working fine now. After this one, we just can use the result. This is like normal attributes, so you can do a lot of stuff with this. Just you can, for example, use the fit function and give it the range between 0 and 180, and just remap it between 0 and 1, just drive other attributes using that. So let me just create these 2 vectors so we can see what we have the visual in viewport. Next point and previous point. So now it's just showing as a color. We just need to just edit, just color to marker, from this one to vector. And the second one is previous one, again marker, vector, and the color probably red. And let me just turn off this one and change the length of the vectors. Now you can clearly see what we have. So you can just assign, also use this, like these vectors we get, use it for other purposes, not just the angle. You can also use these two vectors that we have, use it as a, I don't know, tangent, or use it for a normal if you want to do something really specific, even just one copy line along these distances, these points, so it move from here, continuing these edges or other stuff. And yeah, so this one now is here. Then we have this angle. Let me just create a group node, and with group we can just go to the points and use at angle, for example, is, I don't know, it's like maybe smaller than 91. If I turn off this, or maybe bigger, at angle, yeah, we needed L here. So using that one, you can just group the points. Now, for example, if I want to get point, just bevel between like these 2 points, I can just use a poly bevel like this, and just use the point, select the group, and just do what I want. But as you can see here, we get bevel because this one is like 180 degrees, so also it's bigger than 90. And you can just in the wrangle, so you can just use the if statement here after this, or I can just use another one, another attribute wrangle, and just use the simple if statement. I just get the cd first, cd equal to 0, or we can just go properly 0 0 0, and then just use then if statement. So like if at, I just used f at angle is greater or smaller equal to 45. Just for example, at cd is equals to 100. So this is one statement. And if f at angle is more than 45 or bigger than 45, and is f at angle smaller than 90, at cd is equals to maybe 0 1 and 0, and then you can see we just separated, we just selected this point, and the rest is just the same. We can just go for other if statement here, like let me just copy this, copy and paste it here, and is, for example, bigger equal 90, and it is maybe less than 135, and another condition is going to be like if I just need to change the color, maybe this one is this one, and another if at angle is bigger or equal to 135, at cd is equals to 1 1 and 0. Let me just fix this. Okay. So also what you can do here, for example, for this range, if you want to create a group here, you can just easily do it also here. I add group, for example, group like maybe grp 45 is equal, or just let me just remove this grp, just use this one like this, equals 1. So we also get this group, and let me just apply. I think we cannot start the variable with this, so let's just use a g at the beginning. Yeah, I think now we have this group. Okay, so as you can see, there is no point like inside this, but what if we just copy this and paste it here? Let's see what we get. This is like less than 90, and apply. Yeah, as you can see, we have like 1 point. And the rest, so is the same. I'm not going to through all of this, but you can just use this technique. I just set the color, but you can just do the group here, or you can just use even the group node here to control that. But yeah, this one is going to give you a lot of possibilities, especially if you're doing like a procedural modeling. So just calculating the angles between, and the rest is, I mean, is your imagination. You can do a lot of stuff. I will upload the scene also to my drive and share the link in the below the video. So yeah, I hope you enjoyed this video, and thanks for watching.